Hi, this is James Lee from Team Ada, working with Alex Davis here on Project Hack 8 Challenge 9 Learning from A14 Programme Updates. Before we begin, I'd like to acknowledge the work of the sponsors in the A14 programme. We're building on all the data that you have assembled and prepared. The challenge here is to understand programme changes over time, to understand how the activities may have evolved and how they may continue to evolve in the future, and to use project data analytics to understand questions such as scope and activity changes, metrics that indicate variations in planning, and what features may predict performance, what leading indicators can act as warning signs of delay. So to meet the challenge, we constructed a data pipeline showed across the top here. We understood the requirements and then we loaded the data into Excel, recognizing its volumes. We then used Python and Pandas to manage the data within Jupyter Notebooks and develop Power BI dashboard. We then developed a series of analytics artifacts that comprise descriptive measures and predictive measures, allowing us to then compare predictions with reality using the scikit-learn toolkit. We started with the master schedule, subdivided that across a range of projects, 6 projects, and then further divided those into the date-to-date reporting periods, allowing us to analyse various time phase measures around scope, finish dates, and percent complete. Alex, over to you.
Thank you, James. I'm going to take you through the next bit of the presentation for assumptions, observations, and then our findings in Power BI. In terms of assumptions, we didn't use any, as the analysis and the prediction is based on the available data we had. However, there are some observations around limitations in the data and missing data. Had we had that data, then our analysis could have been more focused. So in Power BI then, on this landing page, what we'll do is we'll go through the overall program and then focus on section 4, one of the most complex parts of the overall program. So in terms of scope control then, first of all, for all 6 projects, you can see that section 4 is by far and away the biggest number of scope changes, which, by the way, scope change is something that's made by a key stakeholder, usually the client or the supply chain, that seeks to add either new activities or modify existing ones, and there's likely to be a time and cost impact as a result. Breaking this information down further, which has been done by writing code through Python and in Pandas, you can see we've got the scope changes here and potentially a rebaseline around item 4 and into period 5, and again later on around about period 11. For section 4 itself then, again in the scope control area, these are then the changes that could cause delay. A lot again in section 4. We've also then got within Pandas produced the leading indicator, key performance indicator here for milestone completion, volatility or uncertainty. So that's driving the uncertainty for particular milestones, and you can see landscape, ecology, project overheads and traffic signs are the worst. Similarly then, some of the better ones in terms of milestone delivery, earthworks and bridge expansion joints and sealing of gaps. Similarly then, we've got delivery confidence. This milestone trend chart has a lot of information in it, provided by, again, Python and Pandas. It shows us that in here, around towards the end of the project, landscaping and paths are the milestones that are delayed. Finally, then, in terms of model training, using scikit-learn this time, we've got these 7 particular charts that all show regression analysis of chosen milestones. The idea being that there'd be future regression parameters of those activity types. The basic benefit here is we can predict the likely completion dates for a variety of tasks. James, over to you.
Thanks, Alex. So in terms of deploying to production, we'd enhance with a range of schedule quality checks and further analytics products, including a cross-activity correlation slip. We'd automate the whole process and we'd look to deploy to cloud, make available to project program managers and enable data-driven project and program delivery. Thank you.
Right, thank you, James. Our sponsor has posed 2 questions. Firstly, were there any activity types that appeared to be particularly unstable? The answer to the word is yes, there were. If we look back at our instability indicator, our leading indicator shows that landscaping and ecology was very unstable and therefore led to delivery uncertainty. in landscaping, turfing and preparation of cultivation, which matches very well with Highways England's website that actually says this is the work they need to complete as part of the work post-road opening. Secondly, then, did we detect any early warning indications prior to activities being delayed? Yes, we did. In the programme overview for Section 4, we can see the number of additional scope being put in to Section 4 peaked in period 4 before rebaseline in period 5. If we then look also at the equivalent for the milestone trends, we can see, although under the white area here, the large number of milestones that have increasingly been delayed. They're moving away from the blue line. And so you can see that there's more stability towards the end of the programme, but this very likely caused the delays in this area. Hopefully that answers the questions.